Okay, guys, in this video, we're going to look at integrating a double integral over the following region. So I went ahead and drew the curve. So we got y equals x squared. So this is x squared, y equals x squared. That's the red. The blue is a horizontal line, y equals 4. And then the orange is the vertical line, x equals 1. So the region is enclosed by these line and a curve. Okay, so how do we set it up? So if we want to do this as a type 1 region, then what we do is we're going to have, well, we're integrating 4x minus y, and then it's going to be dy dx. So y would be inside, x will be outside. So first, look at the x limits. So the x limits are going to be the extreme values of x. In other words, on this region, how does x change from what to what number? So we can see that it changes from 1 to 2, right? So that's going to be the outside limits. They are always numbers. So let's see if we can put that in here. What about the inside limits? So remember that unless your region is a rectangle, the inside limits, possibly both, but at least one of them must have the outside variable. So the outside variable here is x. So either the bottom limits should have x, or the top should have x, or both. So when you look at the region, you need to look for which one is the bottom curve. So which one will be the bottom. So just imagine yourself, you are inside this region. Where is your bottom? Where is your floor? So your floor is the red curve, right? Y equals x squared. And so that's going to be your bottom. And then the top, your ceiling, your roof, or whatever, is going to be y equals 4. So that's just going to be 4 over here. Okay, so let's fill that out. So x squared and 4 here. Okay, but let's go ahead and see if we can compute it. So the first thing we do is we are going to evaluate the inside integral with respect to y. Now think about 4x integration with respect to y. Remember that when we integrate a number, so you have an integral of just k dy, this will just be ky, okay? So integral of a constant, you multiply it by the variable with respect to which you are integrating. So in this case, it would be y. So the 4x is like k, so this is going to be 4xy. Now, y itself with respect to y is the same as y to the power 1. So you add 1 to the power, you're going to get y to the power 2. And 1/2 would go in the front. So the 2 over here must match the power over here. So you add 1 and then you also divide by the same thing or multiply by the reciprocal, which I did 1/2. Okay, then we draw a vertical slash and we're going to put y equals x squared, y equals 4. So what is important is to put y equals. So you're not just saying x squared to 4, because then you are not sure which variable you're substituting for, because you got two different variables, x and y. So you must put which variable. And because the integration was with respect to y, the inside, that's why these are going to be y equals, okay? So let's see if we can substitute. So first we're going to take the top limit that always comes first, and we substitute that for y. So that's going to become 4x, and then 4 goes for y, minus 1/2 4 squared. Okay, substituted that, minus, now let's substitute x squared. So x squared is the second one. We are substituting that for y over here. Okay, so what do I get? 4x times x squared, and then minus 1/2, and then x squared will be squared. So x squared squared. Okay, so let's see if we can simplify that. By the way, the dx is still staying, right? Still staying there. And so we are, believe it or not, still doing part B, because we're still evaluating that inside integral. So this is going to be 4x times x, that's 16x, minus 16 over 2, that's 8. Then minus, this minus will be distributed. So here we got x to the power 1 multiplied by x to the power 2. So these two are added. So that's one of the rules of exponents that everybody needs to know. So that's going to be 4x cubed. And then it'll be plus, right? Because this minus is distributed, 1/2. Now, when a power is raised to another power, so you have the 2 raised again to the power 2, the powers multiply. So that's another rule of exponents you guys need to know. So that's x to the power 4. Now, there is nothing else that we need to simplify here. Why? Because no terms are like terms. So we are done simplifying. We can just put that in here and see if that's right. Okay, so next we're just actually evaluating the integral. So let's go. Let's do that. So 16x, x to the power 1. So we add 1 to the power, that becomes x to the power 2, and then we divide by 2 or multiply by 1/2. Minus, when you integrate in a number with respect to whatever variable, you multiply that number by the variable, because derivative of 8x is 8. So when you integrate 8, you get 8x. Minus 4. Now x cubed, you add 1, so it becomes x to the 4th, and then divide by the same thing, 1/4. Okay, plus 1/2. So now again, add 1, that would be x to the 5, and then 1/5 goes here. Okay, so we are done with that, and then we need to substitute our limits. So the limits are from 1 to 2. Okay, let me see if I can simplify a little bit. So this is going to be 8x squared minus 8x minus x to the power 4 plus 1/10 x to the power 5. And then we need to substitute 1, 2. Okay, what I will do is at this point just give up and use a calculator. So let's do that. And because I do not want to mess up, it's a big chance I will mess up here, because a lot of terms. So first we're substituting the top limit. So this is going to be 8 times 2 squared minus 8 times 2 minus 2 to the power 4th plus 1/10 2 to the power 5. Okay, now generally they usually don't want decimals. So the top limit gave me 16/5. Now I substitute the bottom, which is 1. So everywhere where I see x, I would change this to 1. And let's see what that is going to give me. Okay, this is just going to be 1. And this is going to be 1. Okay, so that gave me negative 9/10. Okay, lost my pen. I'm sorry. 1 second. Negative 9/10. Okay, let's see. So we're subtracting them, right? So 16/5, subtract negative 9/10. And I got 41/10 for that. And let's see if that is correct. All right.